Welcome to the deep dive. We sift through your sources to pull out the really key stuff, giving you the essentials without, drowning you in data.
Exactly.
And today we're digging into Bicentenaria argentina. It's an extinct carnivorous dinosaur, and even its name has a pretty cool backstory.
It really does. We've got excerpts here from Bicentenaria.pdf, which is full of the nitty-gritty scientific details, its classification, bones, all that, but
Yeah.
also the story of how it was even found.
Right, so our mission today is basically to figure out what Bicentenaria actually was, how we came to know about it, and what makes it, special among all the other dinosaurs out there.
And there are definitely some surprising parts to its discovery and even some of its physical features.
Okay, I'm intrigued. Let's start with that name you mentioned, Bicentenaria. What's the origin there?
So the Dus's name, Bicentenaria,
Yeah.
it literally means 200-year anniversary.
Huh. Okay.
And it wasn't just picked randomly. It was named specifically to honor the 200th anniversary of Argentina's 1810 May Revolution.
Wow. Okay, so its actual scientific name is tied directly to a major event in Argentinian history.
Precisely. A historical milestone.
That's fantastic. A dinosaur named for a national celebration. And the discovery sounds, well, almost accidental.
Very much so, at least initially. It all started back in 1998. There's this reservoir in Argentina, the Ezequiel Ramos Mexia Reservoir,
Mm-hmm.
and the water level dropped, exposing these rocks from the Candeleros Formation. And this guy, Raul Spadale, he was out fishing with friends.
Fishing.
Yeah, fishing. And they just stumbled upon some bones and claws literally sticking out of the ground.
No way.
Yeah. And it turned out to be remains from several Bicentenaria individuals, including the holotype, the main reference specimen. Talk about a lucky fishing trip.
That's unreal. A fishing trip bags a dinosaur. I heard Spadale's first guess about what he'd found was a bit off target.
Yeah, just a bit. He apparently started digging them out right then and there, just with, like, a pocket knife in his hands.
Wow.
And his first thought, he figured he'd found a Mechaerodontine.
A saber-toothed cat.
Exactly, a saber-toothed cat. So, quite a different beast altogether. Imagine thinking big cat and then realizing, nope, carnivorous dinosaur.
That is quite a leap. But obviously that didn't put him off. He kept at it.
Oh, absolutely. He went back in 99 and 2000, same small spot, maybe only a meter square or so.
Right.
And this time with a hammer and chisel, but still pretty basic stuff. He dug down maybe less than half a meter and found even more bones. Apparently kept them in a display case at home.
What a story. A true amateur enthusiast. But then the water levels came back up.
Yeah, nature kind of put a stop to his digging for a while. The rising water covered the site again. But his excitement, that didn't fade.
I bet.
He was apparently so jazzed about it, he carried photos of the fossils around with him, showing them to people.
That's passion.
And that actually paid off. A local school teacher saw the photos, realized they might be something really important, and managed to connect Spizio with paleontologists at the Museo Argentino de Ciencias Naturales.
Ah, so the teacher was the crucial link. Props to that teacher. So from that connection, what was the official timeline? When did Bicentenaria get its formal introduction?
Well, the name Bicentenaria Argentina popped up in news reports around June 2012. Then the official scientific paper by Novas and his colleagues came out just a couple of months later, in August 2012.
Okay, so 2012, and we have specific ID numbers for these key fossils.
We do, yeah. The holotype that main reference fossil is MPCA 865. And it's pretty significant. It's the back part of the skull with the rear bits of the lower jaws still attached.
Wow, skull material is always good.
Definitely. And then there's the paratype material, cataloged as MPCA 866. This is basically a collection of loose bones from at least 4 different individuals.
4 individuals.
At least 4, yeah. So it gives us a much better look at the variation in different parts of the skeleton.
So what kind of bones are we talking about in that paratype collection? It helps to get a sense of, what they actually had to work with.
Oh, it's quite a mix. There are bits of the premaxillae that's the very front of the upper jaw. Some even have teeth still in them.
Cool.
A piece of the upper right jawbone, also with a tooth. With parts of 17 vertebrae from the back and neck, 14 fused vertebrae from the sacrum, the hip area,
Okay.
20 tail vertebrae, bits of shoulder blades, part of the coracoid bone from the shoulder, the tops of 3 ulnae forearm bones,
Right.
the end of a radius, another forearm bone, 8 hand claws, which are always exciting.
Definitely.
Pieces of the left femur thigh bone, bits of the pubic bones, partial tibiae shin bones, chunks of metatarsals from the foot, 15-finger and toe bones phalanges,
Hmm.
8-foot claws, and even some rib fragments.
Wow. Okay, so even though it started with a chance find, they ended up with a pretty decent amount of material from different parts of the body and multiple animals.
Exactly. It paints a much more complete picture than just a single bone would.
Right. So we know how it was found, how it got its name. Let's dig into what Bicentenaria actually was. Where does it slot into the grand dinosaur family tree?
Okay, classification. So broadly speaking, it's an animal, a chordate, and then a dinosaur. Within dinosaurs, it's a saurischian, one of the lizard-hipped ones.
Okay.
And more specifically, it's a theropod that's the group that includes pretty much all the meat eaters like T-Rex and Velociraptor.
Gotcha.
Zooming in even further, it belongs to Coelurosauria. That's a big group of theropods, often lightly built, many with bird-like features. And the research places it as less basal than another one called Tucolosaurus.
Less basal, meaning like further up the evolutionary branch, a
Yeah.
bit more derived.
Yeah, exactly. Think of Tucolosaurus as maybe an earlier version within the Coelurosaurs, and Bicentenaria came along a bit later, showing some newer features.
Okay, so a coelurosaur. That often means fast, agile. What about its size? Was this thing huge?
No, not at all, actually. It was a relatively small predator, walking on 2 legs. The estimates put it around 2.5 to 3 meters long.
So maybe 8 to 10 feet.
Right, about that. Think maybe the size of a large dog or perhaps a very small pony.
Yeah.
Definitely not one of the giants.
Okay, that really helps picture it. Small, but likely feisty. Now, what were the specific things, the features that made the scientists say, okay, this is something new? What makes it distinct?
The describing team pointed out several key things. For instance, remember those teeth at the very front of the upper jaw? The premaxillary ones? They have serrations, the little steak knife edges, but only at the very bottom, near the gum line. Most of the tooth was smooth. That's pretty unusual.
Just at the base.
Just at the base. And another thing, in the cheek region, there's a bone called the quadritojugal. Its front part, the branch pointing forward, was twice as long as the branch pointing up.
Okay. What does that mean practically?
Well, it affects the shape and size of the openings in the skull, which relates to jaw muscles. And speaking of the jaw joint, the quadratum bone, the outer surface where it connects to the lower jaw was much, much larger than the inner surface. These skull details point to maybe a specialized way of biting or processing food.
Interesting. Skull mechanics. What about the lower jaw itself? Any quirks there?
Yep. There's a bone called the syringular in the lower jaw. Its upper edge was raised up and had this sort of trapezoidal shape when you look at it from the sides.
Trapezoidal. Okay.
And maybe the weirdest bit is at the very back of the lower jaw, the retroarticular protrusion, this bony extension. It was flattened, kind of widened out side to side, and scooped, like a spoon.
A spoon-shaped bit at the back of the jaw. That's specific.
It really is.
Oh.
And that weird shape probably affected how the jaw opening muscles attached and worked.
Fascinating. Any standout features in the arms or legs?
Yeah, a couple of things. The humerus, the upper arm bone, was flattened from front to back right at the top where it connects to the shoulder. Most theropods have a more rounded or oval shape there.
So flattened arm bone top. Got it.
And near the elbow joint, on the front surface, it had a really deep groove. And then the hand claws, the ones on the outer fingers, had this odd feature. The back edges on the top surface kind of extended backwards, creating a little lip or overhang.
Overhanging claw edges. What would that be for?
Good question. Maybe it helped with gripping slippery prey. Or maybe it was for something else entirely. It's one of those unique details.
Okay, that's a great overview of the key distinct features. Let's dive a bit deeper into the skull since we have some good bits of that. You said the overall shape isn't perfectly known, but the pieces look robust.
Right. Sturdy construction. And that premaxilla, the front bone we talked about with the funny teeth,
Yeah.
it held at least 4 teeth. They were mostly circular when you cut across them. And like we said, most had no serrations at all, but one of them did have serrations just on the upper part of its front edge. So variation even within that small bone.
It's like it couldn't make up its mind about serrations. What about the maxilla, the main upper jawbone behind that?
The maxilla piece they found has a smooth outer surface, but with this line of fairly large little holes for blood vessels or nerves, and the one tooth found with it is totally different from the front teeth.
How so?
It's really flattened side to side, not circular. And it does have serrations, front and back edges running all the way to the tip. And the back edge serrations are coarser, bigger.
So different tools in different parts of the mouth, maybe for slicing versus grasping.
Could be, yeah. It suggests some specialization in how it handled food.
And the cheekbone, the quadrilogygal, you mentioned its odd proportions.
Right, the front branch was way longer than the ascending branch. This changes the shape of the skull openings. Specifically, it makes the lower temporal fenestra, that big hole behind the eye socket, larger. That opening is important for jaw muscle attachment.
Okay, so skull architecture affecting muscle placement. What about the quadratum, the actual jaw joint bone in the skull?
It was solid, no air pockets inside what we call pneumatization. It had a little opening, a foramen, set quite high up. And like we mentioned, that joint surface was really asymmetrical. The outer part was wide, the inner part was only about half as wide. Again, probably affecting how the jaw hinged and the forces involved.
It's amazing how these subtle bone shapes tell a story. And there was even a tiny piece of the brain case found.
Yeah, just a small projection from the base called the processus bicepterigoideus. But it's interesting because it has this deep, wide, hollow area, likely for an air sac.
Ah, pneumatization there.
Exactly. And it's similar to what's seen in another coelurosaur called Stoxosaurus that hints at maybe a shared ancestry or similar lightweight skull adaptations.
Nature's engineering strong but light. What about the roof of the mouth, the palate? Much known there.
Not much, unfortunately. Pretty fragmentary. They have parts of the ectopterygoid bone, which connected things in the palate region. It seems to have had a solid, hook-like projection, suggesting strong connections within the skull.
Okay, let's move down to the lower jaws then.
Hey.
The holotype included the back parts, right?
Yes, the rear portions.
Yeah.
They suggest the lower jaw probably had an opening on the outer side too, another weight-saving feature and muscle attachment spot. The syrangular bone, as we discussed, had that prominent widened top edge.
Right, the trapezoidal one.
Likely for a big jaw-closing muscle attachment. And the very back of it formed part of the jaw joint and extended backwards a bit.
Sounds like a pretty powerful bite setup, even for a smaller dinosaur. Anything else notable about the lower jaw bones?
Well, the angular bone below the syrangular had this distinct oval-shaped hollow on its underside. And the prearticular bone kind of wrapped around underneath it, adding support. Then the articular bone itself, the main hinge part, was robust, solid, no air sacs. And it had that really large, spoon-shaped retroarticular process sticking up and back. That's a key Bicentenaria feature.
The spoon shape again.
Yep. And on the inner side of that bone, there was a smaller bump with a little notch, probably for the chorda tympani nerve to pass through. Just incredible detail preserved.
Truly is. Okay, we spent some good time on the head. Let's move down the body, the postcranial skeleton. What did the vertebrae tell us?
Well, we have vertebrae from different sections. Some from the back were interesting. They had a sharp ridge, like a keel, underneath. And they were opistopsoas.
Opisto what now?
Opistocavizos. Means they had like a ball on the front end and a socket on the back end. Like vertebrae in your neck allows for more movement.
Ah, okay. Ball and socket. Got it.
These also had pluricles, those side pits indicating air sacs. But most of the other vertebrae they found were amphicalelous concaves, or hollowed out on both ends.
So different joint types in different parts of the spine.
Seems like it. These amphicalelous ones didn't have the side pits, but when broken, you could see they were really hollow inside with big air chambers, and their undersides were flat.
Interesting mix. What about the hips and tail?
The sacrum, the fused hip vertebrae. The longest bit they found was 4 fused together, but they think it was probably 5 in total. Pretty robust, solid bones, rounded underneath. Strong connection for the legs.
Makes sense. And the tail?
The tail vertebrae didn't have the pluricle pits, but they did have a groove running down the underside. At the base of the tail, the vertebrae had really long spines sticking upwards, with rough surfaces.
Well, muscle attachments.
Yeah. Exactly, probably for strong tail muscles. And the side projections on these vertebrae were hollowed out at their base. Further down the tail, well, the bits connecting the vertebrae were broken, so it's hard to say for sure how flexible or stiff the middle part of the tail was.
Ah, a little mystery remains in the tail. Okay, what about the arms and shoulders?
Shoulder girdle is pretty fragmentary, unfortunately, but the shoulder joint itself looks like it was large and wide, with a raised upper rim. Suggests decent arm mobility.
And the humerus, the upper arm bone, you mentioned it was flattened at the top.
Yeah, flattened front to back, right at the shoulder end, which is unlike most theropods that have more of a distinct hollow there. The shaft was slightly concave on the front, convex on the back, and it had that triangular bump on the inner corner. Actually, it seems maybe a bit less robust or chunky than you might expect for a theropod of this size.
Less beefy arms, perhaps.
Maybe. And remember that deep groove near the elbow joint, too.
Right, and the lower arm and hand.
One of the lower arm bones didn't have a very big O'Connor process. That's the pointy bit of your elbow that helps extend the arm. So maybe not super powerful extension. But the hand claws, they found 8 of them, pretty strongly curved, flattened side to side.
And they had those weird lips and lumps?
Exactly, on the back edges, both top and bottom, probably for muscle attachments, giving them a strong grip. The researchers noted that the upper lips, specifically, are seen in some very early coelurosaurs and some later ones, but aren't super common. So maybe, just maybe, that specific feature is unique to Bicentenaria and Autapomorphy.
Those claws sound like serious business. Okay, lastly, the hind limbs. Pelvis and legs. What do they tell us about how it moved?
The ilium, that big upper hip bone,
Mm.
it had a low ridge above the hip socket, and on the inside, the ridge where that big leg retracting muscle attached the musculus caudofemoralis longus.
But what now?
Caudofemoralis longus, big muscle running from the tail to the thigh, really important for powerful leg strokes in dinosaurs.
Gotcha. Big leg muscle ridge.
Right. That ridge was really well developed and angled down a bit, and below it the bone was thinner, hollowed out. Down between the pubic bones there was a solid sheet of bone, an apron starting as a sharp ridge. All this points to strong hind limb muscles.
So likely a capable runner, well-muscled back there.
It seems that way, yeah.
Yeah.
Fits with the Coelurosaur profile, often agile predators.
And like you said, being less basal than Tugulosaurus helps kind of place it within that Coelurosaur evolution.
Exactly. It gives us a reference point.
Okay, so let's try and wrap this up. Bicentenaria argentina. It's this relatively small, meat-eating dinosaur from late Cretaceous Argentina,
Right.
named for a major historical event found by pure chance on a fishing trip by an incredibly dedicated amateur.
An amazing story in itself.
Absolutely. So what are the really key things, the big takeaways about this particular dinosaur for you?
I think it's that unique package of features. You've got the weird tooth serrations just at the base on the front teeth.
Yeah.
Specific shapes of those skull bones, like the quadratojugal and quadratum.
Yeah.
That really distinctive spoon-shaped thing at the back of the jaw.
Can't forget the spoon.
Definitely not. The flattened top of the humerus and those hand claws with the overhanging lips. It's this combination, along with its place as a coelurosaur, that makes it interesting for understanding theropod diversity and evolution.
So this deep dive really gives you a solid foundation on Bicentenaria based on what the science tells us so far. We've covered its discovery, its name, size, family ties, and some really unique bone features.
Yeah, it's a fascinating glimpse.
It really is. And thinking about how it was found almost by accident and this unusual mix of features, it does leave you wondering, doesn't it? What else is still out there, buried in those Argentinian rocks? What further clues might tell us more about how Bicentenaria lived, what its world was like, and how these unique traits evolved?
Absolutely. There are always more questions to ask.
Maybe something for you, the listener, to ponder. Perhaps it even sparks an interest to look more into dinosaur paleontology and the kind of research we've been talking about today.